Hello, everyone. Today we are going to continue on the next session of the Basecamp. This time we're going to talk more about snFoundry regarding to how tests working on StarNet, how can we interact and debug with the smart contracts using the Scaffold Stark tool. So this is the team. This is me, Jan. And before it was also Richard giving some sessions. On this part, we're going to talk more about like how tests working on StarNet, and how can you interact with your smart contract using the debug UI from Scaffold Stark. On this part, as you remember before, you already interact and play a bit more with SNCast. That is one of the main commands to declare deploy in both contracts. If you want to use, the CLI interaction. At the same time, snFoundry provides you this snForge that is mainly focused to, to test contracts, smart contracts. In this part, we're going to see more how Scaffold Stark uses this snForge. As you remember, Scaffold Stark is a framework, a tool where you can build apps easily on StarNet, deploy it, build end-to-end apps. It uses a lot of components, but now we will focus more on the Cairo language itself and the snFoundry tool. Why Scaffold Stark? Because it's just very important, especially when you want to join to like hackathons and build MVPs or prototypes. It's gonna help you a lot in this part of like how you interact or debug your smart contracts with the easier to understand debug UI. If you compare with the raw CLI. There are some documentation here that you can explore more about the snFoundry itself. And yeah, if you want to learn more about in general, you always need to check Starlinks to get what's the syntax of Cairo. Then build some challenge, solve some challenge using the speedrun Stark. And now we're going to go into some live coding or live demo. We're going to use Scaffold Stark as a main tool. So in order to install this template, for example, you need to run this command. I'm going to run it. I'm going to open a terminal here, for example. CD, I'm going to go here. So this file is empty. Okay. So I'm going to put this one here. So I'm gonna have to create a project for a name for my project, my app. I'm gonna put it. I'm gonna start some dependencies there. It's gonna take a while, but let's see. Yeah. So while we're waiting for this, as you can see on this part on the Scaffold Stark website, it has everything. It has the extensions where you can, create a better template or a specific template for you. It has the learn that is, the speedrun Star that we mentioned before, where you can solve like a many challenge here. And it also have the documentation that is the most important one that we also will follow in order, how to interact with this app. For example, here, after that, we can go to Wiki Start to installation. First of all, we must install all of these, like Node, Jar, and Git that you guys must have. And we can go to the option number 1, where we can install, all the dependencies that we need for specific for StarNet. If you follow the previous session, you already use this strap also. So it will install off this like Scarp, snFoundry, SDF, extension, StarNet DevNet that you also played before. And after that, you have to run this command, create StarNet later. That is the same as we run it here. So in my case, I just jump direct into this one because I assume you already work on this. Okay, so I'm gonna see my installation on this part. Everything is good. So what I can do is, to jump into my app, call jar change jar deploy and start, but I'm gonna go for this. CD my app. I'm gonna go with cursor to see. I'm gonna make it a bit bigger. This one, no need for now. So as you can see, it's gonna give you a basic template. The most important files, I can say they are here in package. We have Next.js and Foundry. On Foundry, we have more everything related to the smart contract and backend side. So here, one of the main files is on contracts, and we have the scap tomo, but is our we can see what version of StarNet of Cairo we are using. That's 2.16. And as you can see, also we are using like a StarNet snFoundry that is for the testing, and a few more details that we will cover again. And the main smart contract is this. This is the template of the smart contract we are gonna check. So if we follow this part, we will see, okay, CD jar install, you already have it. And then you need to follow here, for example, in order, to have all the required installations, we need to check this with HDF install, check if you have some problems. Otherwise, just, check also this option too, if you want to run Docker, but we can skip it this time. The dependencies, the setup, okay. We go into the next one, it's like a jar chain. So what we're gonna do right now in this part is we're gonna interact direct. We're gonna start doing the debugging with Scaffold Stark. It's gonna be like easier this way. So we're gonna start doing the debugging. So in order to do that, I'm gonna close this. We need to run the jar chain. So I will go to my cursor. Now, always double check that you have the jar install working, because we did the installation before. Now it's kind of quick, so I'm gonna follow the jar chain. So jar chain is gonna do is gonna, run a local devnet for me. Okay, I have a local devnet here. It is gonna be easy for me to test this smart contract because I'm gonna deploy the smart contract on this devnet, on this devnet. So the next things I can do is to jar deploy, but first I will try to with jar compile. Jar compile is gonna, at his name itself is gonna compile the smart contract and generate some like internal files that we can use it. It's good. Of course, if maybe I don't know if something is wrong here, it's not gonna compile. Yeah, I'm gonna put here jar compile again, and it will detect something is broken, or here it's broken because I mess around. So I always need to check if it compiles. Right now I'm gonna run jar deploy. What jar deploy does is it's gonna compile again. As you can see, it's compiling, and at the same time it's deploying on the local devnet. As you can see, this has been moving because it has deployed the smart contract. Okay, good. And now what I'm gonna do is like debug this smart contract. I'm gonna do this yarn start, so we can start interacting and debugging with this smart contract. Even though we didn't have a deep dive into smart contract, we are just gonna start interacting, and then you later can understand this much better. Okay, we have this running on this part. We can go to here to local to see if it is working or not. Okay, is live already? Let's see. Okay, so this is the main debug UI that we have. This is just the first page. So on this hub, we have many options, the facet, the block explorer, what is the price of a Stark, what is the wallet that has been connected here. In this case, we have other options, how to connect on this part. We can connect to DevNet with any of these, but ideally we need to connect with the burner wallet. It's the easiest one. And we can choose any of these burner wallet that are linked to the DevNet, to the local host DevNet. Okay, cool. So go to the main point. What we have here is like, okay, we have deployed a contract called your contract. How do we know that? Because as you can see, this is my contract name, okay? Contract name, your contract, and is the same as the one that we have on this part. Script TS, deploy contract, deploy TS. Here, yeah, we have a contract, call it your contract, that is the same as this one. So we, right now, when we deploy here with this jar deploy, we deploy this your contract. And that's what we can see on this part, yeah? On your contract. Okay, so what happened here is like this your contract have some basic functions, basic like read functions. This is the read function that doesn't need any input, parameter. So by default, when we created this contract, we assign this like a build unstoppable apps string. There is a premium variable that has a value of false. We have the owner of this contract, that this is this address, that is the same as this one. And I think we have some write options. So we have this greeting, but we can set greeting, means we can change this value. And few more other values there that we can check as well also. So what can I do now is, okay, I have this value that has been, has been set up by default, but I can update it. So I can put like hello open build. And I can go send. So as you can see, the smart contract now has been changed. It means like the value of this like greeting variable has been changed from building apps to hello open build. Yeah. And this happened also on this part. As you can see, something has been changed on the DevNet. Um, but yeah, just now. So we can keep, creating more or updating more on this part. Something interesting on this is like, okay, how do we change this value? Because we don't have any set premium. The way we change is like, okay, I have this option here also. If I want to set this like, if I want to update this greeting value, I can provide also some like star tokens to these smart contracts. It means like, okay, I can update this like, 大家好, and then I can pass here some value that, okay, I will say I will transfer to this smart contract 1 star token. So with this, I'm saying, okay, I will interact with this function. I'm gonna update the greeting variable, and at the same time, I'm gonna transfer something here, 1 token, 1 star token. And after that, this variable will be updated to true. We will do that, but as you can see, we'll get the error because the thing is like, if we want to interact or with the smart contracts there that are, transferring tokens from here to there, before everything, what we need to do is to interact with the contract itself and request some approve. It is more related to the how ERC20 tokens work here. If you have a ERC20 token, you always need to approve first, and then later on, you need to make the transfer. In this case, we are trying to do the transfer first, but cannot. That's why we need to first to go to this part, to the star token. Remember, the star token is a smart contract itself. So as a smart contract, we need to get some approved that someone will spend some of his star tokens on some smart contract. So here, if we go to approve, and this part, we need to say, okay, this 064 user, because it's the one that is interacting here. So this user will spend some amount of tokens when he's interacting with this smart contract. So we need to pass what is the smart contract that the user will interact and will spend some uh, star tokens. So here we need to pass the contract that we deploy. This is your contract, so we're gonna copy this, come back here, go to approve. I'm gonna paste this. And here I have to say, okay, I'm gonna spend 1 star token. Yes, I'm gonna go 1, complete the zeros because we need to put all of the zeros. And then, okay, I just did the first step. It means like this user, that this is me, that I'm interacting with this smart contract. This user has approved that he will spend some star tokens on this contract, your contract. Okay. So since we did this first step, now we can execute this function because this function will try to spend some money, yeah, from your side. But you already approved this kind of like spending. So okay, now we can try it one more time. And it has been executed. Now the new value of greeting is Taja How. We have this premium that has been updated to true, yeah? Because before it was like a false. So this is the main part, or this is like a overview of this contract interaction. But now we're gonna jump into the code. Okay, we did the interaction, but we will jump into the code. So what we did is like we deployed this smart contract and we did some interaction, but we will check more how does the smart contract looks like. First of all, we have this first block. So on this first block, we have this like we define like a public trade. It's where we define the interfaces of our smart contract. So we have decided this smart contract will have these interfaces like a greeting, set greeting, withdraw, and premium. You always need to start with this annotation, starnet interface, and then public, because we want to read it later, like a public trade. The name of this like an interface, and this is like a generic value. There is something that we will deploy and instantiate later, but we don't know yet, so we just call it like a generic. But this is gonna be something related to the contract state to the smart contract, yeah. And on this part, we say, okay, we're gonna have a function greetings that is gonna have a snapshot, a simple reference to the generic value that I'm gonna initiate here, instantiate here. And this function will return a byte array. And a byte array is something like you call it like a string, kind of like a string type. It's not exactly a string, but we can call it like a string type. Set greeting, okay, we're gonna have a reference of the smart contract. In this case, it's still a generic, but the reference is gonna be like a mutable reference, okay? Because we're gonna change something here. This is gonna be like a set, so we're gonna change something. So we're gonna make a reference, a mutable reference, using this keyword. So if we use this like an operator here, it's gonna do it as immutable reference. But with this part, we're gonna do a mutable reference, okay? We will need to pass the new greeting and the amount of star that I will, transfer on this part. We have this withdraw function where we can withdraw the money that has been, allocated into the smart contract, and the premium that will return if the user is like a premium or not, true or false. Okay, I have defined this interface. Later on, I have to go into the next module, I can say, onto the next like component that, no, let's skip module into the next module. So this is where the smart contract itself is going to be allocated. So we need to put this always like this annotation, and then create a module with the name of your smart contract. This part I'm gonna skip. It's gonna take me some time. I'm just gonna go direct into the storage. So after we create a module of our smart contract, the most important part is the storage. So we need to, annotate the storage with this part, create a struct called storage. And then here on the storage, we need to define what we're gonna, what are the variables that I'm gonna use on my smart contract. We have the greeting variable, that this is a byte array, the premium, that's going to store up true or false, the total contract, that it's going to store, how much, mm, how many times, how many users have interact with this smart contract, yeah? User set greeting contract, so I'm going to map the users, how many users has been interacting with this smart contract, but this time I'm gonna store their address. Yeah. And something interesting here is like we have something called super storage. So this super storage is linked with this ownable. So here on this part, I have a logic about how ownable work in this smart contract. Ownable means like who is the owner of this smart contract and who is actually able to to edit this or to create some or to update the state of these smart contracts and the variables. So all of this logic has been encapsulated and reduced thanks to OpenZeppelin. So on this part of OpenZeppelin, we are importing this ownable component that is going to have his own like a logic. The ownable component has his own logic that is very similar to smart contract, but it's not. So in this part, we don't need to write this logic. So we are gonna reuse this component from OpenZeppelin. That's why we need to do a few more steps, like also complete this uh, component with a path, storage, and event, because this component itself is gonna come with his sub storage with some events that we can reuse. On this part, for example, we are saying that this ownable component can expose some functions that has been defined on his side, and my smart contract, can also use it and expose these endpoints. So later the UI can read it. Here we have located saying that we will use some internal functions from the ownable component. It's okay. And as you can see, we can create in our smart contract, our event, but we can reuse this ownable event, from this part, from this ownable component. But besides that, we can create our own event that is looks like this. You can have a look more. So yeah, so this is very important part because component is one of the most advanced techniques we can say. And if you know how to use it, your contract is going to look very clean and very powerful, no? And at the same time, you will use, something that has been audited from OpenZeppelin. So you're using something that is very, barrel tested instead of using or creating your own logic. Okay. Okay, cool. So we already have defined the storage with all of this. And what happens here is like, okay, we have defined a constructor. And usually this constructor is gonna be, called once we deploy the smart contract. On this script, we deploy the smart contract. We call it your contract, and we have to pass the arguments for the constructor. Yeah? In this case, we need to pass the deployer address, who is the one that the deploy account the account that is deploying this smart contract is going to be the owner. Yeah? That's what we're saying. And we define the details of the function here. A constructor is going to be always like using this annotation and using this name. Here we say, okay, we have this variable greeting that may have like a nothing. Yeah, it can be like an empty. It's like an empty string. Can be an empty string, but we are gonna deploy again saying, okay, building awesome apps in this case. Yeah, it's a bit different. If we run here again, for example, jar deploy, it's gonna deploy again the smart contract, but in this case, by default, this is gonna be the new value of greeting. Okay, so if I go to here, you can see now the new value is building awesome apps. Yeah, that is different than the previous one. So and then yeah, you can keep working and playing around with this. Yeah. And at the same time, when I'm creating this, deploying this smart contract, I'm saying, okay, I'm gonna call this self.ownable. That ownable is this component that I just like attach or inject here, and it's calling this initializer. But this initializer is I didn't define anything on this part, yeah, because I'm reusing what is done on the ownable component. So if you want to check more, for example, we can go to the open sapling part. Here, for example, I'm gonna go to this part, open sapling. Open sapling. Let's go to this 2.0. On this part, I can check on these components. You can check more about, this like how components work and how can you use it on your smart contract. We have this here, accounts. Let's see, accounts. No, here ownable component. So this gives me more, details about what's going on with the ownable components. As you can see, there is a function called initializer. So in this one, yeah, the ownable component has an internal implementation that is the initializer. As you can see, it has implemented this. Here I need to pass the owner, who's going to be the owner of this like a smart contract. And I have to pass this data type, a contract address. Let's see here. Also emit an event that you can check more. But yeah, so definitely you can check more on this part. Better if you just go, direct to the GitHub. It's gonna show open sapling contracts here on this part. This is more for the Solidity one, but you can check for the Cairo contracts. Make sure you are using the right tag. That is the 2.0. Yeah, and you can go into this one, yeah. And then you can start working. You can check here how is the initializer. Yeah? You can find this function and check more what's going on there. Okay. So with this function that I'm reusing for the ownable component, I'm just gonna say, okay, this owner that I'm passing here is gonna be, this contract address is gonna be the owner of this smart contract. If we go below, we are doing the implementation of the interfaces. On this part, we define the interfaces, but here below, we are gonna implement these interfaces. So in this case, I need to pass a contract state in this part, not a generic anymore. So this contract state is gonna be the smart contract itself contract state. So I just can read, if I need a function greeting, I just read the self greeting that is gonna go to the storage and read it. Set greeting is a bit more like, okay, there is more logic here because basically I'm gonna say here, if I'm gonna give some amount of Stark, I'm gonna change my premium to true. We're gonna see. If I don't pass any amount of Stark, I'm gonna change this premium to false, this user to false. But remember, yeah, always if you wanna transfer some like tokens of star tokens or any other tokens here, what you need to do is to create an instance of this smart contract or instance of this token. So you need to create get the star token contract address that I'm getting this way. And then you need to call a dispatcher that's going to help you to instantiate this start token contract. So we have this here. So after this is instantiated, we can execute a transfer. Yeah, can execute a transfer. It means like get caller address, the user that is interacting with this, smart contract. is gonna transfer some star tokens to the contract address. Yeah? The get contract address is the the address of this like your contract. So okay, so get caller address is gonna be the user that is interacting with the contract and will send some amount of Stark to the contract address that we interact in. That is the your contract. That's what we are saying on this part, yeah, to the Stark dispatcher. So some the Stark some like star tokens we will send from this like user wallet balance to this contract address. Okay, and then we will emit an event also here. You can check how is it. We also have this like withdraw function that we can check it a bit later, and premium. So yeah, this is just like a big overview how this like a smart contracts how is the logic of this smart contracts working. So the next part that we're gonna jump now is the testing part. As you can see, there are some tests here that we have on this folder, test contracts. It's very interesting. So besides to deploy or to interact with your smart contract using the Scaffold Stark debug UI, you also can run the test, yeah? And this yarn test, what it's gonna do is like internally, it's gonna run the commands of StarNet Forge, yeah? Or snFoundry Forge. As we can see, we have defined on this part that we're gonna use StarNet Forge for our testing. Something has been failing here because maybe I changed something around. Should be the right message. We will check this soon. Let me see if I updated something here. I have any ideas? Oh yeah, here I have updated something, so that's why my tests are failing. That's good. So I'm gonna remove this part, so my test will pass for now. Now I do jar test again. Oh, as I was saying, okay, we're gonna explore more on this, how this test working. So as you can see, we are into this file. So the first thing that we need to check is like, okay, we have this like this two tests that has passed. Okay, this two test has passed. I'm gonna remove which one. I'm not gonna use a Scaffold Star UI anymore, so I'm gonna remove this one to make it easier. I'm gonna put this DevNet also no need. Okay, as you can see, they have two tests that have passed. First test is set greetings. So, and the second test is okay, some like a transfer. So I'm gonna check this one. So in order to build this like a unit test, first we need to do is like we need to create a instance of this smart contract that we have here, the your contract. So in order to that, we need to create an internal function called deploy contract. So this deploy contract will simulate, the deployment of the contract that you want to work. So the details are here. I'm gonna just leave this one to you to check more. So basically here I'm gonna just be saying, okay, I'm gonna deploy your contract, yeah. This can be any name actually. This is just like a byte array, but in order to keep it consistent, we're gonna call just your contract. So when I deploy your contract, it's gonna just give me like an address, and after that I have to also to get the dispatcher, because with this dispatcher will allow me to interact or to get access to the entry points or to the functions. So this first step just gonna deploy the contract, but I just have the address, So with the address, I cannot do that much. I just look at the address. But with the dispatcher, I can access to the functions of this smart contract. That's why we need these two steps. Deploy the contract get the address of that contract, and then associate a dispatcher. So with the dispatcher, I can access to Git to this like a greeting function. That is this one, yeah. That is this function. I can access to this one because I have my dispatcher here like live. So with this function, I'm gonna get what is the current value of greeting. Okay, good. And then I'm gonna put this a bit more here. And then I need to test with what is the expected value, yeah? Since I'm deploying, I'm saying that on my constructor, this is gonna be my string. So my expected value should be this one, yeah? And then I'm just gonna jump into assert and then it's gonna compare, yeah, the current value of greeting with expected value. And if it is not working, if there is something wrong, it will emit, some like a error message. Okay, something happened here. Should have the right message. Same for here, for example, on this case, on this first block, I'm just checking if after I deploy my contract, that the default value is the correct one or not. And then after that, I'm gonna update this greeting, okay? I'm gonna create a byte type. I'm gonna put in like a um, second like value for this or a new value for this. I'm gonna call the set greeting. I will pass this, value set greeting. Just give it a clone in case. And here, this set greetings, I need to pass two values. Yeah, let's see here on this part. Set greetings. I'm gonna move a bit more this here. I need to pass the new message and then the amount of Stark that I'm gonna pass. But this is an option value. But in this case, I'm not gonna pass any kind of tokens or money. I'm just gonna give it like no. No means like we don't transfer any star token. Yeah, okay. And then again, my dispatcher will read the new value. Yeah, the new value of greeting, and this new value should be and then this new value should be the same as this new greeting. Yeah. So that's why if I run this test, it's gonna run like okay. Jar test is gonna execute this part. Yeah. To test. The first time is done. The second test is taking longer because I will show you how later. Why later? And then it has passed. I'm gonna put this first, maybe. Yeah. I'm gonna comment this for now. For example, like I can see it's gonna fail because before I put like awesome, yeah, build awesome apps that is different than build unstoppable apps. So if I if I like call the test, it's gonna fail, yeah, because he said okay, should have the right message. That this is the error message that I'm getting. I set up here, yeah. So something is wrong there. That's why it's not passing. So I'm gonna. Sorry, it should have the right message on this part. Okay, so I'm gonna just revert this. On this part, okay, is correcting. It's like we can see that test is working well. Now we're gonna go into the next part of the test. Is this one that we're going to we're going to enable now again. This part is a bit more interesting because I'm gonna fork the blockchain but on testnet. It means like this fork is thanks to this part, for example here. On this part, on this like a scarp, I'm saying that I'm gonna use snFoundry for my dependencies. That's mainly for testing. Here I'm gonna do some like a setup. saying that I'm gonna enable this fork for snForge. I need to pass the URL of the RPC in order to, to read this fork of the blockchain on Sepolia. I'm gonna fork all of this until the latest block, has been produced there. Okay, that's good. Since I have this enabled, I can go here and I can do the test and fork. I'm gonna say, okay, I'm gonna fork this Sepolia blockchain. And what's gonna happen is like, okay, let's go one by one. I'm gonna simulate that this smart contract is running on the Sepolia, yeah, on Sepolia block, on Sepolia testnet. So for that, I will need a user that lives or is live there on the Sepolia blockchain. So have this lead user, let's call it the owner in this case. So I'm gonna go here. Okay, this owner has been used also, to deploy the smart contract. It's good. But what is the address of this owner? It's actually this one, yeah? So this owner that we use it is actually a real wallet deployed on Sepolia. So how can we test that? So we go to this part. If we go to, I'm gonna start closing some of them. I'm gonna go to Voyager. So on Voyager, that is, the block explorer. I'm gonna put here on Sepolia. And I'm gonna paste this user that, okay. And as you can see, what happens is like, okay, we have a account contract. Remember that on Starnet, we have smart contracts itself, but also account contracts. Yeah, there are like the wallets that lives on Starnet, and even they say, okay, this is a ready wallet, yeah, because you also have Bravo's wallet and a few more others. Okay, this is a wallet address that is live on a smart contract since 2 years ago, exactly almost 2 years ago. It has some balance. It has some balance on Ether and Star token and few more. And that is good. So I can use this user that is on Sepolia to start, testing my smart contract. So okay, I have this owner I have this user that is the owner of the smart contract, because here I'm passing, I'm saying that this owner is gonna be this contract address or account contract address is gonna be the owner of this of the smart contract that I'm deploying. Okay. So that's why, okay, I have this lead user, it's gonna be the owner. I'm gonna deploy your contract that it's gonna have this user as the owner. I'm gonna instantiate the dispatcher of your contract because I will need to call some functions. Then I will need to instantiate ERC20 dispatcher. In this case, it's going to be the star tokens because I will need to transfer some star tokens. So I need an instance of this smart contract. So as you can see, it's very useful. Yeah, I have an instance of your contract. That is this one. I also have an instance of the ERC20 token that should be that is this star token. Okay. And then I have defined this amount that I'm going to transfer. I'm going to transfer just, something very little, like a 5-way or 500-way. And then this is important part, the cheat caller address. Remember this cheat caller address and few more things has been like import from snForge. Yeah? So at this point we are using snForge already. As you can see, snForge, we have import all of these that I'm gonna explain most of them. And on this part we have this cheat caller address that is coming for snForge. Yeah? That is the tool that call it like a snFoundry. So what happened here is like, okay, what we gonna do is like, we're gonna call some approve. Yeah, remember before in our previous manual example that we did with Scaffold Stark, before we execute some transfer, we need to do some approve. So in this case, on the test, you have to do some approve also. And remember, when you have to do some approve, you have to go to the StarNet token contract. So what we need to do here is like on this testing environment, we have to call this cheat caller address. And we will say, okay, now we have to interact with the star token contracts. This is the meaning. We have to interact with the star token contracts. And the one that will interact is this user that I have defined here. And it will interact for a span of time of one. So maybe just one operation like this. So okay, into this testing environment, I need to set up this, yeah? Because by default, when you do the testing, you interact direct with your contract. But in this case, we need to interact with Starlet token contract. So we need to call this like a cheat called user, cheat called address, and we have to say who is going to interact with this Star token contract. Okay, nice. So I have defined this, and then I have already the instance of this ERC20 dispatcher, and I have a proof here. It means like this ERC20 token has a proof function that what it needs to do is like, okay, this user is gonna, approve that some amount of star token will be spent on your contract address. That is this one, yeah. So this is what we say on this part. Okay, it's good, and then we have to make sure, yeah, if this has been executed or not. So after that, after this block has been executed, we need to double check with allowance. So for allowance, anyone can call this actually allowance because it's just a read function. You don't need too much setup. So in this case, I'm gonna call again this ERC20 dispatcher. But in this case, I'm gonna call the allowance function. This is a read function that I'm gonna ask, okay, how much allowance that this user can, spend of this started contract on this like your contract that we deploy. And this approved amount should be the same as this amount to transfer. That should be 500. Okay, that's why, okay, I'm gonna make this assert now. So I'm gonna put like this to make it, to keep it simple. And I'm also gonna keep like this. Okay, I'm just gonna test this first assert. Yeah, test. It's taking a while. Okay, that's good. Something else that you can see here is like you can also use prints here. For example, what I can do is like I can print what is my balance here on this part, for example, or what is this value even before I make the assert. So what I can do here, for example, I'm gonna print my balance before so. I'm gonna keep it from some cycle let balance of user, okay. And I'm gonna print, and I'm gonna do the third. I'm gonna print balance of user. I'm gonna put here just like this. So I have this dispatcher. I'm gonna say balance of this user. Okay, it's gonna read how much star tokens I have, and then on this part, since I have this let approved amount, I'm gonna see actually how much is the approved amount. Yeah? Print approved amount. Okay, here. So you can also see on your test how much is it. It's giving some warning because I'm not using this fork, but as it's supposed to be used, but it's okay. This part is good. Balance of user. So they say I have this amount of tokens in terms of star tokens, and the approved amount that has been set here is 500. That is okay. That is the same as 500. That's why this assert has passed. Yeah. And so as you can see on this test, we are reading what is the value of a wallet that has, some balance on support. Yeah. That is very powerful. So they say I have 46.7 star tokens. Let's see here. If I go to Voyager, if I have star token, I have 467. Okay, 3K star token. Okay, that's okay. That is the same I have here, 4673. Okay. This part is okay, so I'm gonna uncomment this part. So in this part, the second part is like, okay, I'm gonna set again a string, but in this case, since I'm gonna transfer some amount of money, again, I need to call this sheet caller address in order to set up again the environment. That's saying, okay, the user is gonna interact with with your contract, with the contract that we are using now. Okay, then after that, I'm gonna execute this transaction or this transfer. I'm gonna call the dispatcher of your contract set greeting, new greeting. But in this case, I'm gonna pass the amount of transfer. Yeah? That is a bit different than this contract, for example. I just call set greeting, but I didn't pass anything here. I just pass no, like nothing, empty. But in this part, I'm gonna pass the amount of token to transfer. I'm gonna make the assert. Yeah? Assert your contract dispatcher should be, the new greeting that I'm expecting. So your contract, your greeting option. So here we transfer 500 away, it's okay. So I'm gonna call again this function. For example, what else I can do here is that, for example, since I transfer this 500 way here, I can check again what is my new balance here after I have this, after I have executed this. I have somehow here on let user new balance, and it's gonna give me the new balance of the user, and should be, this part should be like 47 like this. I'm gonna do it again because on this when we executing this test, we are transferring 500 ways, so my balance should be, decreased. Yeah. So as here you can see 5277 4777 because I transfer 500 way. Okay, so as you can see, StarNet Foundry is very powerful tool. For example, this part you can put just like a mainnet latest. And you also can start working and testing how your app will behave when you interact with, smart contracts that live on mainnet. That's why it's like very, very, very useful when you want to build like, production ready apps. You need to do a lot of testing. And this is one of the main important ones that we included here, yeah, on this part. As I mentioned before, we have all of these resources that I expect you guys to can check more. As you can see on the Standard Foundry, this is a very, very huge uh, huge like a book where you can find more ways to to play around. You can use it here, like maybe use more of these things that you can read here, bring it here live to the Scaffold Stark like a base test files. Okay, that's all for today, guys. We explore how to interact with a smart contract on Scaffold Stark, and how Scaffold Stark make use of Forge, that is this tool that is inside the snFoundry tool as well. Okay, that's all for this video. See you next time.